bucka. Ha. You know the deal.
The first thing we're going to talk about in our number sense unit is something called place value. And one of the first questions you're probably going to ask yourself is, well, why do we need that? Why do we need place value? Well, the reason we need place value is to represent larger or smaller numbers in our number system. Now, the next question you're probably going to ask yourself is, well, what does he mean by our number system, or what is our number system? Well, first off, the reason I call it our number system is because it's the generally accepted way of writing values for human beings all across the world. So when I say our, I mean the human race. And our number system is called a base 10 number system. I'm going to talk about what a base 10 number system is in a minute, but first you might ask yourself, well, are there other number systems? And the simple answer to this is, well, yes, there are other number systems that have existed in the history of the human race. One example of another number system is called Roman numerals, which you might be familiar with. So in Roman numerals, we have a variety of symbols that represent values. So for example, a single line or a tick represents 1. And in the Roman numeral number system, so 2 ticks would represent a value of 2. So then these 4 lines here would represent a value of 4. Now, the Romans could have continued just drawing these ticks to represent larger and larger values, but they probably realized, well, it's not very efficient if you want to write a very large number to just keep writing these ticks. So they had to come up with other symbols to represent values. And once they got to 5, they did come up with another symbol. And it's what we would call a V. It looks like a V in our alphabet, and that V represents a value of 5. And as the Romans got to larger and larger values, they came up with other symbols. And we're not going to do a whole lesson on Roman numerals, but these are just some examples. So X represents the value of 10, L is a value of 50, and C is a value of 100. So this is just an example of another number system that has been used in the history of humankind, and there have been others. But again, our number system is called a base 10 number system, and we're going to talk a little bit about why that is next. And the first question you're probably going to ask yourself is, well, why is it called that? Why would it be called a base 10? Number system. And there's a variety of reasons why it's called a base 10 number system. So one reason it's called a base 10 number system is because we have these 10 symbols to choose from to represent values. And by grade 6, you're familiar with these symbols. From 0 to 9, those are the 10 symbols that we have in our number system to represent values. So then you might ask yourself, well, what about values larger than 9? And in our number system, rather than coming up with other symbols, so like, for example, in the Roman numeral system, they came up with another symbol to represent a value larger than 9, to represent 10. But in our number system, we didn't want to have any more than these 10 symbols. And so to represent these larger values, this is where the idea of place came in, to represent larger values. So to represent values larger than 9, in our number system, we use what are called places. And those places, they continue to represent larger and larger values. And the places increase in value as we move to the left. So we're going to take a look at what that means with an example next. So here again we have our 10 symbols that we have to use in our base 10 number system. And right now we've got the values from 0 to 9 represented. And as we just talked about, well, we need to have a way to write values that are bigger than 9. And what's happened here at this point now is we've run out of digits. We don't have any more symbols to use once we get to 9. So as already discussed, what that means is in our number system, we have to move to the left, and we have to start putting values there. Now, what value is there? Well, right now there's nothing written there. So if we wanted to, we could put a 0 in that place. And putting a 0 in that place doesn't change these values at all. So for example, our first value there, it's still nothing. Writing 2 zeros is the same as writing 1 0. Moving our way down, 0, 3 is still a value of 3. So the fact of the matter is I could put as many zeros to the left of these numbers as I want to, and it wouldn't change the values here at all. But now that we've run out of digits to write here, we've used our 10 symbols to represent values up to 9. Again, we have to work our way to the left to write increasing values. So to write the next value up from 0 in that larger place to the left, we have to put a 1. And then in our 1's place, we start over again with 0. And this place here is called our 10's place. So this value now represents a value of 10. So this is how we represent values larger than 9. We don't come up with another symbol. We continue to use the 10 symbols that we have, but we write a place further to the left. Then we continue our pattern here. So we're going to stick with one of those values in that place to the left, and then continuing counting by 1's, we continue using those 10 values that we have to write increasing values. And we continue doing that again until we run out of symbols to use. Which we now have. So we've written our 10 symbols in the 1's place from 0 up to 9. And now we've run out of symbols. So again, our value to the left has to continue increasing, and it's going to increase in using the symbols that we have to use. So our next larger value after 1 is 2. And then the pattern starts over again, 0 in the 1's place, and so on. So this pattern of continuing to use these 10 symbols would continue. So I just skipped a bunch. We're not going to count in 1's forever here, but I skipped a bunch, and eventually again we would get to having a 6 in our 1's place, and a 9 in the place to the left of that, and continuing our way down, increasing here. Now we've run out of digits to write in this place and in this place, so again we have to continue by putting a value to the left. Well, what value is there right now? There's nothing there right now. So again, we could put zeros in that place if we want to. It doesn't change the value of this at all. And since we've run out of symbols to use, we have to continue working our way to the left, and after our 0 comes 1. And in the next places, we start all over again with our zeros. And then increasing by 1's, we just continue the pattern, going up by 1's until we run out of symbols to use in this place. And then we'll increase this place by 1. Continuing on and on, and we continue working our way to the left for larger and larger values. So this is how our number system works, how our base 10 number system works, using the 10 symbols that we have to use to represent larger values. So the next thing I'm going to talk about is the actual names of these places. But just before we do that, there's a few different ways we have to write our numbers. So we can write our numbers where we have the values all just kind of clumped together like this. Or oftentimes you'll see numbers are written in this way where there's a comma basically for every 3 places. So the places are in groups of 3, and sometimes commas aren't used, but spaces are used. And again, it's in groups of 3s here. For the rest of this video and for the rest of this series on number sense, I'm gonna use this way. I'm gonna use the commas, and we're gonna see why that's kind of a handy way to write values in terms of trying to identify the places. So the names of our places in our number system work in groups of 3 essentially, and I'll start with the smallest group here, because remember, as we move to the left, our values get bigger. So as we move to the right, our values get smaller. So furthest to the right here, these first 3 values, that set of values is called our ones. And moving further to the left here, our next set of 3 places, that set is called the thousands. And continuing our way to the left here to even larger values, this set of values here is called our millions. And the biggest set that we have here, moving further to the left, is called billions. Now, there are larger values than this. We could continue working our way left, and there are names of the values that get bigger and bigger, but for our purposes, we're going to stop at the billions. So these are groups of values here, but as you can see, in each group, there's 3 different places, and each of those 3 places has its own name. Now, the nice thing here is the first value in each of these sets of values here is the name of the set. So here, our first value in our ones place, the place furthest to the right in our ones place, is simply just called our ones. Now working our way to the left, getting to the bigger value that we have here, well, that value is 10 ones. So once we've run out of our 10 symbols to use from 0 to 9, we have to start putting values in that place, and that's called 10 ones. And continuing further to the left, once we've run out of digits to write in those first 2 places, we have to continue working our way to the left to represent larger and larger values, and that's called 100 ones. Now continuing our way to the left, again, as already mentioned, the first place in each set of places here is just the name of the set. So what we have here now is the thousands place, because that's the first place in our set of thousands. And continuing on, the next place that we have here is our 10 thousands place, because once we got to that place, we would have 10 thousands. And working our way left, continuing on, well, once we got to that place, we would have 100 thousands. So the name of that place value is called our 100 thousands. Well, as we've already talked about, now we're in our next set of values here, and the first value in that set of values is always just the name of that set. So now we're up to our millions. Moving further to the left, the name of our next place value in this set is 10 millions. And finally, the last value in this set that we have, you've probably already guessed it, and hopefully you guessed, that's called 100 millions. Now, you're probably starting to recognize some patterns in terms of these names within the sets of the names. You probably notice that each time it starts with the name of the set. So for example, our first value here is our ones because it's in our set of ones. Our first value here is called thousands because it's the first value in our set of thousands. And our first value in this set is called millions because it's the first value in the set of millions. And then working our way to the left, we then have 10 of those values, so 10 ones, and then 100 of those values, so next 100 ones. In the thousands place, to the left of the thousands, we have 10 thousands, and then we have 100 thousands. And then we have the name of the next place, millions, 10 millions, 100 millions. So what I'm going to encourage you to do here is try to figure out what the name of the next 3 places are on your own. Now, as previously mentioned, mathematicians are notoriously lazy, so in order to save a little bit of time and effort and space and thought, mathematicians realized, well, with these first sets of values here, it does follow the pattern that we've talked about in terms of the first place is the name of the set of the places, then we have 10 of those and then 100 of those, just as it does follow that pattern here and here. But to save a little bit of time and space and effort, mathematicians thought, well, let's not bother calling it 10 ones and 100 ones. Since it's the first set of these values, let's just shorten that a little bit, and instead of calling it 10 ones, let's just call it tens. And similarly, instead of calling it 100 ones, since it's the first in the set of this pattern here, let's just call it hundreds. And again, it was just a matter of being a little bit lazy about it and just saving a little bit of time and effort. Since it's the first in the set of these values, we don't have to distinguish it from the other values. We can just say, well, 10 ones is tens, 100 ones is hundreds. After that, though, we have to indicate in the thousands that we have 10 thousands. We can't just say tens there because it would get confusing with the smaller value of tens. So again, in our first set of values, the pattern still follows, but instead of calling it 10 ones, we just call it tens. Instead of calling it 100 ones, we just call it hundreds. So to finish off our lesson on place value, I'm just going to ask you to identify the name of the place for each one of these digits in this very large number. So this number here, which again I've used commas to put the places in groups of threes, it's a very large number. Essentially, can you identify the name of the place that each one of these digits is in? So the 0 is here. What's the name of the place that that 0 is in? If you're able to answer that for all of these digits, congratulations, you now have a firm understanding of place value.